Good afternoon, friends. People are joining, still joining. We are 33 at the moment. Let us wait for half a minute before we proceed to the presentation. It is very nice to see you all, which is second time in the same month. We met 5th of August and today we are meeting again on 24th of August. So thank you so much for sparing your time. I'm seeing many new names in the list of attendees today. It is quite encouraging as well as satisfying to me, and that there is no dearth of learning or the learners in our community. Many people are coming and joining and learning new things. It has made my belief more stronger that there is no end to learning and irrespective of the age. So let us keep learning new things in your respective areas. So today's webinar is one step in that direction. I express my gratitude and extend warm welcome to all the attendees who are present and who are going to be joining very soon. As you know, following the MOEF notification, we conducted a webinar on 5th of August, wherein we discussed and we explained the 5 innovative ways of upgrading your existing APC devices in your premises. We also went through the 2 new technologies, which are the most advanced as on date. One was the wet technology, another one was the dry separation technology. And in that series, today we are going to address a very special gathering. And that special gathering is those who are consuming a difficult kind of biomasses in their boiler and helping this nature and the society by reducing the greenhouse gas emissions, as well as consuming this waste, which otherwise are creating a lot of pollution in and around NCR. So, friends, today we will be discussing the best available technology in the world, what we call it in short form BET, best available technology. All the European standards are designed on BET. It is whatever technology best available in that country or around the globe, they make their norms according to the condition of that particular technology. So today we shall be discussing the technologies which is the BET technology for these mustard husk as well as for paddy straw, which are creating a lot of troubles in and around NCR, as well as many people have started using it after the government of India has mandated minimum 20% even in thermal power plants, this biomass usage and reducing the coal consumption. So before I begin, let me make a quick survey, though many people are still joining, but let us make a quick survey. I would request everyone, whosoever is present, to go to the chat box and just write what fuel they are using in the boiler. Just write the name of the fuel. Let me see what type of gathering we have today. So accordingly, I can address if it is not paddy straw or mustard husk, maybe something else similar to that. So I can address and connect my presentation according to that. So please write what type of fuel you are using in the chat box. We'll have a break for 1 minute to see that analysis. Thank you so much. A lot of responses are coming, and I see the varieties of biomasses being used as a fuel. And the main category, if I divide it into 3-4 category, the mustard husk is topping the table, followed by crop residues, and then bagasse, and then rice husk, wood chips, bark, and so many other soya husk, coffee husk, Julia flora. So thank you so much. Thank you so much for this. This represent that even there are a couple of friends from outside India, they are also responding and they are also using similar type of fuels in their boiler. So friends, one thing is clear that many people are using and now today we shall be discussing what are the ingredients when we are using these fuel, what normally the problems we are facing. Today's presentation is divided into three parts basically. The first part will establish the need. And the second part will describe the technology, the best available technology for this particular applications. And the third part will give you what the way forward for achieving the emission norms of even as on date, we have 50 milligram, but maybe tomorrow or after 5-6 years down the line. So we will be focusing what upgradability those technology can come with, so that you don't have to change everything every time whenever the norms are changing. So we shall be discussing all these aspects in today's discussion. So my sole objective of today's presentation is basically to make you prepare or to keep you ready the moment these norms of 50 milligrams are mandated in next couple of months. So you should be ready by that time that which technology is most suitable for your application and what are the advantages or disadvantages of all those alternate technologies. So friends, before I start today's presentation, as you know that every new learning needs high energy. So let us just review the ground rule because there are many new attendees today. So let me just revise the ground rule. The first ground rule of this whole session is to maintain a high energy. So please maintain a high energy, be interactive, use the chat box as much as possible whenever we are discussing something or some interaction is required. And the second one, please keep your phone on silent mode so there is no disturbance and you can focus on something new learning today. And the next ground rule is that please respect the IP. Do not click the photographs of the slides. If you need something, please ask us. Our backend team will send you in next 48 hours. So let us begin today's presentation on this best available technology for paddy husk and mustard husk fired boilers. So I'm just sharing my presentation. I hope my voice and audio and video is clear to everyone. Please, if yes, please write yes in the chat box. Am I audible to everyone? Thank you. Thank you for your response. Is this slide is visible now on the full screen? My backend team, can you please confirm?
Yes, it is visible.
Okay, and changing? Slides are changing?
Yes, yes.
Okay. Okay, friends. So let us start today's learning session on best available technology. We shall be calling it BET from now onwards. Emission control in mustard husk and paddy straw fired boiler. And today's focus is going to be to meet the new emission norms or the upcoming emission norms of below 50 milligram per normal meter cube for the boilers above 10 TPH. So before we begin the technology part, let us establish the need. What are the problems on these fuels and why the problems are there? So if you look at the ash analysis of these two fuels or the difficult biomasses, these are the category, the typical biomasses or the difficult biomasses. And similar to that, there are other fuels also like which we mentioned the Julia flora and you have palm, EFB and other fuel also of the similar nature. So what are the common constituents in these particular fuels which creates problem in the ESP or back filter or wet scrubber? So if you look at the highlighted, yellow highlighted compositions, that sodium, potassium, these are the alkali metals which these biomass have got a substantial amount of this, especially the mustard husk. The potassium is to the range of 20%. Just a moment. There is something wrong. Yes. Is the slide come back again? Prakhar, can you just confirm?
Yes, the slides are back.
Okay, thank you so much. Okay, so mainly the potassium, sodium, chlorides, and other these compositions, these elements, they are very sticky in nature. They have got a higher resistivity. The composition as such on these fuel, the resistivity is electrical resistivity is higher as compared to coal and other fossil fuels. The particle size, especially in mustard husk, is very, very fine. So submicronic particle size is there. And the most critical part of whole biomass application is the varying moisture content in the biomass. Maybe in 1 month you get a good moisture content, but next month if the rainy season is there, suddenly the moisture increases, and that spoil the whole setup, especially on the pollution control side when you have a back filter, especially. So these are basically the nature of the fuel or the characteristic and morphology of the fuel, which creates the problems in the APC devices or the existing technologies. On the other hand, the emission norms are getting more and more stringent. If you look at the overall picture on biomass generated power, you see that by reducing from 150 milligram to 50 milligram per normal meter cube, we are going to clean our environment by more than 1.3 lakhs tons of fly ash. And this is considering that as on date, we are producing approximately 10,000 megawatt of power from biomass, either from the cogeneration sector or maybe independent power plant, biomass-based power plant. So considering this and considering the PM10 and PM2.5, we are going to clean the environment by more than 1.3 lakhs tons of fly ash, taking that the biomass potential which exists in India can be consumed in next couple of years, and the thermal power plant also starts using the biomass. As on date, it is about 50,000 tons, but in successive years to come, when the biomass proportion is increasing in all the thermal power plants, then this figure may touch about 1.3 lakhs tons of fly ash, which is quite a big amount as far as the environmental pollution is concerned. And the present and comparison between the existing norms and proposed norms, if you see the boilers, all boilers above 10 TPH are now 50 milligram per nm cube as against the earlier norms of 600 milligram. And especially in NCR region, people are still trying to get more stringent below 30 milligram. Most of the plants are aspiring to get below 30 milligrams. And below 10 tons, the emission norms are still 150. I mean, earlier it was 800, but now it is 150, and less than 2 ton, it is 500 milligram. So our focus today is going to be on below 50 milligram for all those boilers which are having, because this particular sector which we are addressing today is mostly having boilers of 10 ton, 15 ton, 20 ton, or maximum 60 tons. And other norms, especially regarding to the continuous emission monitoring system, CEM, all the boilers above 10 tons would require CEM to be installed on the chimney as per the new proposed norms. So this is on the norm side, or the mandatory emission norms. Now, let us review what are the, in this particular sector, what are the prevailing technologies which are mostly available as on date, and what are the concerns on this the customer or the operators are facing. So majority of the plants of this category are still with cyclonic separators. So first one is the cyclones, because the earlier norms were 500 and cyclones were able to meet in most of the cases, barring some few cases where the cyclones are not designed properly. Otherwise, cyclones are capable of meeting below 500 milligram. So majority of the sector is having cyclone as on date. Some people have upgraded in past to ESP, some to back filters, and some have got a scrubber also in line. Wherever the cyclonic separators were not working and people were targeting below 150, especially in the boilers above 10 tons, they have gone for either wet scrubber, back filter, or ESP, in addition to the cyclone. Now let us see if these four technologies are present, what is their conditions, what are the concerns on each category of these technologies, and why do we need something beyond this? When we want to do below 50 milligram, then why do we need to upgrade to the technology? Why can't we change in this and do something to have below 50 milligram? I hope everyone is following the content so far. Please write yes if you are following. Thank you. So let us see one by one, take one category at a time, and then see what are the different concerns of the industry on these technology. Let us first take the back filter. Back filter on paddy straw or on mustard husk do have certain limitations and certain serious concerns. And the major concerns which I have highlighted here are restricted operating range of temperature of flue gases. As you know, the back filters are designed, especially the high temperature cutoff is there. In these fuel, when the alkalis are there, even the low temperature cutoff is also there to avoid the damages or the clogging of the back filters. So the restricted range of temperature is the back filter can operate. Whereas in these boiler, especially the temperature of flue gas varies after operation of maybe 4 or 5 weeks. The fouling takes place on the pressure parts and the temperature of flue gas keeps going up. At some point of time, you find that it is going beyond the design temperature of the bags and the system has to be bypassed. So this is one of the serious concern on these back filters. The high recurring cost, because the back filters here in most of the cases are put up of 100% PTFE, which is quite costly. Plus it needs to be replaced. The life of the bag is estimated to be maximum 3 years at the moment on these difficult fuels. So high recurring cost every 3 years, you get about 30% of the project cost or 20 to 30% of the project cost on replacement of back filters. High energy consumption, as the back filter technology goes, you have minimum pressure drop of about 150 millimeter water column. So the energy consumption is higher than ESP and all. Fire hazard, of course, because the bags are, after all, is a fabric bag, though it is PTFE and coated and all, but still it has a threat to fire. If some unburns are clogged in the within the bag filter or some ash is not removed timely, then there are chances of fire hazard. There has been some accidents on and cases of fire on these fuels. And frequent choking of bags is a very, very serious phenomena, because the moment if your moisture content in the fuel is going constantly, then things are okay. But the moment suppose the moisture content is up or the temperature is down, then if the choking or the clogging of bags takes place, then it is very difficult to even remove that choking by the purging. So this can set up a permanent damage on the bags in many cases. So these are the basic concerns on the bag filters. When we come to the ESP, because of the sticky nature of dust, like potassium or sodium salts, they get, though they can be charged easily, but they get stuck to the collecting plates, and the amount of wrapping, what you either you have a hammer or Maggie wrapper, it is very, very difficult to clean the surfaces by wrapping. So what happens, the cleaning is not perfect. So over a period of time, you see a big deposits on the collecting plates built up after 2 months or 3 months, and then it starts losing the efficiency because the migration gets reduced. So this is one problem, that wrapping is not enough in ESPs. The resistivity of dust, certain constituents or the composition of these biomasses, the resistivity is a factor. It is not as good as we get it in the coal or other fossil fuels. So it is difficult to get charge. You need a high voltage to charge on those particles. Plus the high quantity of fines is there in these biomasses, and that lead to the inconsistent efficiency from the ESP, especially due to the wrapper reentrainment. Because during the time of wrapping, you see a lot of particles or the ash particles are going, emissions are going from the chimney. So ESP, though it is workable, people are using it, but they are operating it with these concerns, and it has to be properly taken care of to avoid to have the consistent results from the ESP. Wet scrubber is another technology which has been used on this particular application, and there are concerns. Though the wet scrubber is workable, it can give you a normal wet scrubber can give you below 100 easily, and a good wet scrubber, if it is designed properly, can lead to below 50 milligram also on these fuels. But the question is, do we have the water in those plants? So water scarcity in most of these plants, which are firing mustard or other biomass, is one factor because of which the uses of wet scrubber has been limited over a period of time. It also generates a liquid effluent, and that liquid effluent has got a lot of TDS because of the solubility of these alkali base in the water. So when you have a high TDS, then it becomes very difficult for dewatering system to operate. If it is a TSS, the suspended solid, you can easily do it like in Vegas. But when you come to these typical biomasses, the downstream system becomes more and more complicated. And these are the issues on wet scrubber. Of course, the energy consumption is more or less similar to the back filter in this case. Cyclone, we are not talking much about it because they are outdated and they are not able to meet the current norms of 50 milligrams. So Cyclone could be used as a pre-dust collector, but it cannot be a final product of APC, which can lead you to 50 milligram or even 100 milligram as on date. So friends, if you go through these concerns on the prevailing technology, we find that the characteristic of the ash and the constituents of alkalis, chlorides, and other base material in the ash composition has got a lot of effects. I would say has got a lot of adverse effect on the performance of these APC systems. So what should we do? So limitations, if I summarize everything, the limitation on the existing systems is basically because of these parameters. And if I read it, the fine particles, the ultra fine, as you have more proportion of fine, it is more difficult for the APC to, design becomes more complicated. Sticky nature of dust, as I mentioned, highly corrosive because as you go into the wet system, the corrosion is also an issue because of chlorides and other corrosive elements. Hygroscopic in nature, yes, this is also a very typical nature of these dust, that it captures the moisture very fast from the atmospheric air. So it is hygroscopic. The moment it captures the air, it gets stick to the electrodes or to the surfaces of the APC devices. So hygroscopic in nature is another element which has creates lot of havoc in these technologies. High alkalis and no space for upgradation is a physical parameter which has got a restraint in most of the plant. The space is not there for upgrading these equipments. So these are basically the limitations the people or the industry is facing on these fuels as on date. So if I summarize everything and put down the consolidated pain points of the industry. So consolidated pain points of the industry that they are already using a difficult biomass, helping the society to reduce the pollution, helping the society or the planet to reduce the greenhouse gas emissions. But their pain points are growing because of these factors. Like if in a normal mustard husk boiler, you see the input dust concentration or the dust concentration from the boiler is to the range of 5 to 6 grams per normal meter. Whereas in paddy straw, it is a high dust fuel and it exceeds beyond 15 grams per normal meter. The current in most of the plants, cyclones are there. Those cyclones are not able to meet the norms. This is a pain point, definitely. ESP and bag filters do have some limitations. This is another pain point because they do not know where to go, which way to go. If they use ESP, they have some concerns. If they use bag filter, they still have some concerns. So what to do? Wet scrubbers, if they do, still they have some concerns on dewatering and all. So the technology limitations are there. So this is another pain point which industry is thinking and suffering with all these issues. High recurring cost. In couple of technology which people have gone, they are having a high recurring cost of replacement of bags or replacement of electrodes every after 3 years. With all these pain points, the government is also tightening the rules. They have also reduced this emission norms to below 50. Majority of plants are not interested to use the wet systems because of water scarcity or because of dewatering system, hassles of dewatering system, and the space limitation. So these are these 8 points basically beyond which, around which the industry is now focusing and finding and trying to find out a solution to this problem. So whatever technology we are doing or whatever technology we are proposing or thinking to upgrade, so that technology should have these points which I have listed in a summary, that whatever technology you are thinking, it should have a compact footprint because a space is limited. It should have a low operation cost because the plants are not so big. They are having a boiler capacity ranging from 10 tons to maybe 50, 60 tons maximum on these fuel, exclusively on these fuels. So the operation cost of any technology, whatever we are thinking or proposing, should have a low operation cost. Easy to operate is another parameter which the new technology or the proposed technology or the upgraded version of these technologies should be very easy to operate, because the kind of manpower these industries are operating manpower these industries are having, they are not at that level which operate the power plant or the big plants. Whatever technology we select should be able to handle high resistivity of dust, because in biomass there are many parameters of many composite this constituent which have a very high resistivity of dust and difficult to charge. And also it should take care of the varying nature of fuel, percentage of moisture in the fuel, because no one can guarantee you to have the same moisture in biomass throughout the year. It keeps varying. We can have a cut down at high or low level, but it keeps varying. Nobody can guarantee a constant moisture content. So whatever technology we select finally should be able to sustain the operation at varying moisture content. The fire hazard should not be there. Easy expandability or upgradability should always be there, because in India right now the norms have got down to 50 milligram, but maybe after 5 years, 10 years, again the norms may come down to 30 milligram, because we are just moving towards the European standards gradually. So time is not far that we will have to face these norms of 30 or below 30 milligram. So whatever technology we select today should be able to upgrade without much of a expenditure or with the minimum capex requirement at that time for below 30 milligram. And the technology should be able to overcome all the limitations of ESP and back filter. Either it should replace or it should complement. Either way it is possible. If it can complement the limitations, then also it is a good combination. Or if it can remove those limitations completely, that is also another solution. So we will be discussing the new technology based on these parameters which we have listed, how the new technology is getting qualified on all these parameters. So what is the solution? So before I go ahead to the solution, I would like to have a feedback from all of you in the chat box. How are you finding it so far? Is it going well? Are you able to receive the content so far? If yes, please write in the chat box. If you have some comment, please that also you write. So thank you once again for your response. So let us talk about the solution. Now we have understood the concerns. We have also established the need from the new technology. What is the expectations? What are the expectations of the end users on the technology as far as these two complicated nature of fuel is concerned? So now we will go to the second part of the presentation, which defines the technology. So the technology which we are talking about, which is the best available technology on these difficult biomass or difficult nature of fuel, is EGB, which is electrified gravel bed precipitator. It is a type of ESP, but it is vertical ESP, and the principle of operation is just reversed of ESP. In ESP, we talk about the migration and the current. Here we talk about only the potential difference or the voltage difference. So this technology has been bought by Enviropol from USA, and it was developed way back in 1980 in MIT, and it has been used extensively on all these complex nature of fuels in US and European countries, and there are about 100 installations worldwide as on date. So we shall be discussing what is EGB, because many of you may not be knowing about EGB. So let me just explain you the system configuration of EGB, how it looks like and what is the accessories attached to this. So if I explain you, this EGB is basically a cylindrical vessel. It can have one vessel or it can have two vessels depending on the sizing or the volumetric flow rate of the gas and the dust quantity. So within this vessel, there are gravels. When I say gravels, these are stones, pea gravels, normal gravels, which you get it from the river. So there is this complete section is filled with gravels, and this thickness of the gravel bed may vary on various design input parameters and desired output parameters. So what we do, we ionize the gas particle to the negatively charged to negative charge, and then the gas passes through this gravel bed. It could be top to bottom and bottom, or bottom top entry to bottom outlet, or reversed. It can be designed in both ways. So this is the EGB portion, and then below EGB we have a gravel feeder which control the speed of the gravel evacuation from the vessel. Then we have a gravel cleaner at the bottom. This is the gravel cleaner where you can see my cursor. And after the gravels are cleaned, they go back to the EGB through a bucket elevator. So bucket elevator is also part of the system. And the dislodged ash particles from the gravels are cleaned using the pneumatic pressure. and the dislodged particles from the gravels are taken through a pneumatic conveying using a small dedusting fan and separated through high efficiency cyclone, and that goes to the silo, and this dedusting air, which is almost 2 to 3% of the total flue gas quantity, is sent back to the circuit. So this is the total system, which consists of the EGB, the ionizer, dedusting fan, gravel cleaner, bucket elevator, a small cyclone, and then the connecting duct and pipe. So this is the system configuration for an EGB. Now let us see the principle of its operation, how it works. As I mentioned, that exhaust gas first passes through an ionizer, which is a pre-charger basically, which charges the particle. This has got a TR set and this has got an ionizer, where the particles present in the dust, in the flue gas gets negatively charged. And when the negatively charged particles are passing through this bed, gravel bed, which is electrified, giving a voltage of 20 to 30 kV. So these are the discharge electrode which are embedded into the gravel bed. And when the electrodes are given a voltage of 20 to 30 kV, this gravel bed, whole gravel bed gets polarized. It gets a balanced charge. The half part of the gravel gets a negative charge and other half gets positive charge. Because gravel being a non-conductor of electricity, it receives the voltage and then gets statically charged from all sides. So when the negatively charged particles are passing through this gravel bed, which is already electrified, the gravels captures the positive side of the gravels captures the negatively charged particles. And this gravel bed is continuously moving from top to bottom because of the gravel feeder at the bottom. The RPM of that can be controlled, and accordingly the speed of evacuation can be controlled, and efficiency and the pressure drop can also be controlled by doing this. So by the time the gravel reaches from top to bottom, it takes about 5 to 7 hours in evacuation of this gravel bed. And when by the time it reaches from top to bottom, it gets completely coated with the fine ash. And when it comes out from the electrical field to the gravel cleaner, the electrostatic charge on the gravel gets over, and the particles which are attached to the gravel gets loosened up, and they get coagulated. So when a small pressure, the pressure of about less than 1 kg, when it is given to the air pressure is given, it gets cleaned immediately. And the particles which were deposited on the gravel gets cleared, and you get a ash which is having a higher size of particles now because of this coagulation and the flex process of sticking together on the gravels, right? So this is what is the principle of separation of particles. And if you look at the collection efficiency of this, it has got a very, very high collection efficiency. This is the curve which has been demonstrated, and it is the outcome of all the 100 installations which are working for a long time. And if you look at the collection efficiency versus the particle size, you find that when the gravels are charged with 20 kV, the collection efficiency of 2 micron, up to 2 micron particle is almost 100%. So this is a big achievement as compared to the ESP. ESP maximum efficiency at 2 micron is not more than 95-96%. Here we are getting 100% efficiency up to 2 micron. Below 2 micron also, the efficiency is very, very good. It is varying from 99.9% to 99.6%. And if you have voltage, lesser voltage, then this green curve is reflecting. And with 0 voltage, that means if the TR set is switched off, then only the mechanical separation through the gravel bed is also quite encouraging and quite handsome in that way. And you find that particles of 4 microns are almost separated even without the electrification of the gravels. So this is blue curve is showing when the zero voltage is given to the bed. I'll now show you some videos. Please see these videos carefully. The left hand side is the bed, moving bed from top to bottom. You can see how the gravel and what this speed of gravel, which is coming from top to bottom in the AGV. Very, very slow process. And gas is passing through this at 90° from this vessel. And the second video, which I am this middle one, is the gravel coated with ash coming out from the electrostatic field and going to the gravel cleaner after cleaning the gas. So you can see how the gravel, you can see some loose ash on the gravel when it is moving. It is because of the electrostatic field is over. When it comes out from the electrostatic field or out of the EGV vessels, the ash particles which were deposited on this gets loosened up and then get separated easily by a pneumatic pressure. And after cleaning, in the gravel cleaner, you see how the gravels gets cleaned. This is the operation of gravel cleaner, where the mechanical and pneumatic both pressures are used to clean this gravels and take the ash to the cyclone through a dedusting fan. So I hope these video can give you a lot of insight. And you see the clean gravel. This is the clean gravel, and this is the ash deposited gravel. So just a check to all the attendees if it is okay so far, the videos were interesting or not. Please respond with yes or no in the chat box. Okay, thank you. So let us now see what are the advantages of the EGV as compared to the prevailing technologies on various counts. So the first advantage, if you compare it with standalone ESP, is that the total collecting surface area of the gravel, one vessel of this size is having around 100 tons of gravels. And if you calculate the collecting surface area of these gravels divided by 2, because we are presuming here that only 50% positive side is going to be active, even though in actual scenario, the gravels keeps tilting when it moves down. And sometimes the one part is negative, sometimes the other part is negative. So 70 to 75% of the surface area of the gravel is practically used for depositions. So if I take that count and calculate the total surface area, it is 10 to 20 times more than the ESP electrode. I repeat, it is 10 to 20 times more than the collecting surface area of the electrode, which covers almost 4 to 5 times footprints as compared to this. So we have a large collecting surface area at a very, very small space which it covers. Gas distribution is not a problem because the resistance posed by the gravels due to the gravel bed automatically distribute the gas evenly throughout the vessel. Unlike in ESP, where you need to have a proper GD gas distribution plate, carry out the test for ensuring the proper gas distribution to all the electrode surfaces. Here, that is not a problem. Power consumption again is very, very low here because we in TR set, the power consumption theoretically is zero here because we are only using voltage. There is no current. So the power consumption is only limited to the auxiliaries item like the bucket elevator, gravel feeder, and one dedusting fan. And if you add it to these three items, then it comes out to about 10 watt per 1000 meter cube per hour of gas flow, which is very, very low as compared to the ESP, where you have a pneumatic conveying system, compressors, and then TR sets, and then so many rotary valves and all. So as compared to that, the power consumption is very, very low. It has got a very, very high efficiency on submicronic particles, as I showed you on the graph. Below 2 micron, this has got a fantastic efficiency, which no other technology can meet this. It can handle high resistivity gas, unlike ESP. This is another very big advantage as compared to the normal ESP. In ESP, the most important or critical parameter is the resistivity of dust. If you have a high electrical resistivity, the collection efficiency and the charging voltage, that gets varied. The collection efficiency is very low. Otherwise, you will have to go with a very high voltage charging. So here, because there is no current, you don't have to migrate the particles. Only the potential difference is used for collection. The resistivity is not at all a factor. Rather, if the resistivity is high, the performance is going to be better in this. So it is just a reverse principle of ESP as far as the resistivity of dust is concerned. Another big point, or I would say another big advantage, is no wrapping re-entrainment. The biggest flaw in normal ESP, especially on this fuel, is the high emissions during wrapping. And that is because of the fine particles gets carried forward during the wrapping cycle of the ESP fields, especially when the second and third field is getting wrapped. Then you see good amount of emissions going from the chimney. Here, all the gravels, which are the collecting surface area, are coming out of the gas path at the bottom. And there it is getting cleaned. So there is no connection between the gas path and the cleaning process. So there is no chance of re-entrainment of particles. Whatever you have collected are collected. They cannot go back and fly back with the flue gas of the in the chimney. So this is another big advantage as far as the wrapping re-entrainment is concerned in ESP. Gravels are cleaned outside, modular shape design, footprints are very, very low. As I said, it is 1/4 to 1/5 of ESP. And this you can say disadvantage or advantage, but it is a modular design. You cannot have more than certain size of the equipment. If you have a bigger boiler, you will have in multiples. So I hope you are enjoying this session so far. I'll now like to show you a couple of references worldwide on this technology. And this is the installation in Sweden, which I have seen it personally running on a wood-fired boiler, rubber wood-fired boiler, consistently for the last 15 years. And the emissions, which I seen from my eyes, is below 6 milligram. And their record also says it was designed for 10 milligram, but consistently they are getting below 5 milligram, 6 milligram emissions from this boiler. This is the installation recently done on a spent wash fired boiler in India, and this is attached with 2-field ESP, because in a spent wash the input dust concentration is very, very high. So we had used ESP as a pre-dust collector for the coarser particles, and the fine particles are captured in this vessels or the EGB. And this has been demonstrated at 50 milligram per normal meter cube. Other installations in the world, you can see the installations on left-hand side and on the right. These are on wood and wood-based dryer application, less than 10 milligram. Then on typical biomass application in Sweden and again in USA on below 10 milligram. MSW application, municipal solid waste in North America, less than 20 milligram. And there are few more. I mean, in India, because this technology came only 3-4 years back, and now it has started picking up slowly and gradually, and we are already making, or some orders are under manufacturing in our workshop in Greater Noida. You can see these EGBs under manufacturing. This is the EGB vessels, then you have lowers, and then you have inside capsule, and then within this capsule and this vessel the gravels are filled. So this is the discharge electrode case which is embedded into the bed, gravel bed. These are insulator housing. This is another EGB which has been made in knockdown condition because of the size. These are couple of EGBs under dispatch to various industries. So I hope everyone is clear now about the technology. If yes, please write clear in the chat box, and then I will proceed to the next stage of the presentation, the third part of the presentation, a way forward. Thank you, friends. Thank you for your quick response. It indicates that everybody is alert and listening to the presentation carefully and learning something new. Thank you so much. So now we will discuss, can the EGB be used directly onto the boilers? What are its limitations? So the biggest limitation on EGB that it is not advisable to run for more than 2 grams per normal meter cube of input dust concentration. Reason is it can work above 2 grams, but there has been some research on this particular topic. There has been some lot of work done in USA before this 2 gram was specified as a maximum input dust concentration for this equipment is because of the gravel speed. So up to 2 grams, the gravel speed is very, very minimal. I mean, it is within the range of not creating the abrasion to the vessels. If you go to more than 2 grams, then your gravel speed has to be increased, and then it creates some amount of abrasion, it starts picking up on the gravels. So the best thing is to use this equipment as a polishing filter. Take out the coarser particle, which any technology, normal or simple technology, can remove all those coarser particles, and use it only for fine tuning of removal of fines and reducing the emissions to very, very low level. That means the boilers of mustard husk or paddy straw, where normally the inlet dust concentration for the boiler varies from 5 grams to 15 grams, only EGB cannot work. It has to have some pre-dust collection before EGB. So now I'm going to specify an integrated way forward for these two type of boilers. The best available technology for paddy straw could be a MEPA, which is maximum efficiency particulate abatement, having an ESP of 2 to 3 field attached with EGB. I showed you the photographs of a spent wash boiler, and similar to that, this paddy straw would work very, very nicely on this combination. For mustard husk, because this input dust concentration is about 5 to 6 grams only, so the cyclonic separator followed by EGB can be a good combination, and we call it as a cyclo EGB. So these are the two variants of EGB depending on the type of pre-dust collection before EGB. So as I told you, the MEPA is for paddy straw, is a combination of ESP and EGB. So whatever are the limitations on EGB, whatever are the limitations on ESP, the EGB can complement and use it as an advantage to give you the consistent emissions of below 50 milligram or 30 milligram, as the case may be. So this combination, we call it as an integrated model or the hybrid model. And the trade name, which is already patented, is MEPA, Maximum Efficiency Particulate Abatement System. This is the most advanced as on date in the world under the category of dry separation technology. The existing ESPs in these plants can also be upgraded by just adding. The conventional way of upgradation is to keep adding the number of fields in the ESP. But in most of the cases on such fuel, that doesn't help you after some extent. I mean, it helps you to bring down 100, but bringing it down below 100 or below 50 becomes a challenging task on such fuel, which has a varying nature in terms of moisture and which is very, very sticky, as we discussed about this characteristic of these dust. The other way could be to upgrade your ESP is to add EGB at the outlet funnel. So without adding much of a footprint, maybe if your outlet funnel is about 3 meter or 4 meter, you don't need any extra space when you upgrade your existing ESP. If there is no space, then EGB can also be planned in the side of ESP by just rotating the ducting to that side. Okay, so these are the upgrades available for ESP. Then we come to the mustard husk fired applications, where after a lot of discussions with the various stakeholders on this particular fuel, we have come out with a solution which is very, very simple, low maintenance, or I would say least maintenance, a combination of cyclone, a good cyclonic separator attached with EGB. So this is the model. We can have a tremor cyclone depending on the volume of flue gases, or we can have a twin cyclone as well. The advantages are two-stage separation. You have a cyclone as well as EGB. So two-stage separation, if something goes wrong with one, others can take care to great extent. So two-stage separation, primary separation by cyclonic separator, secondary separation by EGB, modular design and very compact footprint. This for a 15-ton boiler, this everything can be finished in 6 to 7 meters. This whole system. Least recurring cost, because there is nothing here which gives you a recurring cost excepting the gravel, replenishment of gravel, which is not more than 20,000 to 30,000 rupees per year. Only 10 to 20% of gravel is replenished, because during the travel of gravels, some gravels get, because of the frictional losses, that size gets very smaller, and there is a system attached to this, a grit separator, which keeps separating a very fine gravel to remove from the system. So it keeps maintaining the level. So the consumption is not more than 10 to 20%, and the cost is not more than 20 to 30,000 rupees. So recurring cost is almost, I would say, nil or the negligible. It is a very simple and sustainable solution. There is no maintenance prone item here. All are static in nature, excepting one bucket elevator and one dedusting fan of 5 kilowatt. Complete system is static in nature. So there is no chances of high maintenance like in ESP. Sometimes your hammers are going, sometimes RAB is troubling, sometimes the wrapping system is getting broken. So here there is nothing of that sort, and this combination with EGB and cyclone makes a very, very easy and very, very compact system for the mustard husk fired boilers. Upgradability to below 10 milligram is very easy. You need to only change the bucket elevator speed, the gravel size. You can go at a higher efficiency and reduce the emission levels. You fill the smaller size of gravels. You plug those bigger gaps within the gravel bed. you get a better efficiency and also reduce the gravel speed at the same time. So you can get a better efficiency of the gravels of the EGB. So upgradability to a greater extent is very, very easy to perform on these EGBs and cyclo EGBs. This is the overall PFD, process flow diagram with the cyclone. The cyclone, then the EGB, and then you have this this gravel cleaner, feeder, and then gravel, this bucket elevator, and then fan, and then chimney. And this is a gravel hopper. And number 10 is your fan. So you can use either a back filter here, a small back filter, or can use a cyclone depending on the type of dust for dedusting. For mustard husk and paddy straw, we can have a small cyclone designed for dedusting of that small quantity of air. The cyclone diameter would be around 300 to 400 mm, that's all. So we are approaching towards end of this session with a conclusion. The best available technology for paddy straw is MEPA, an integrated solution of ESP and EGB. Whereas the best available technology, the bet for mustard husk, is a cyclo EGB, which can give you below 50 milligram very, very easily, and is upgradable to even below 20 or 10 milligram in future. So friends, I would like to appeal to everyone who is working on these fields to have a serious review on their existing technologies, the problems they are facing, and map it with these two new technologies and then call for action. I mean, everybody is listening and thinking that this is a new technology in India, so why should I go first? Let others install it on this field. So I would like to clarify on this that this is not a new technology. This has been innovated in 1980s in USA. There are more than 100 installations in worldwide on typical installations, typical characteristics of fuel. The purpose of innovation of this was only to address high resistivity dust and sticky dust. You can go to the website and see this innovation at MIT on this USA for this electrified gravel bed precipitator. The purpose was only to address the sticky dust and high resistivity dust, which was not they were not able to do in the ESPs or even in the back filters. So this is not a new technology, maybe new for you because we are listening it first time. It is relatively newer for the Indian market because we have just launched it 2-3 years back. And the first installation was on the most difficult fuel you must be knowing is spent wash, that is the slope in the distillery, which contains 30 grams as input. Dust concentration, very, very sticky in nature as compared to the solid fuel fired, which we are talking today, paddy and mustard husk. The spent wash is far, far more critical. And there it has become a success. So why not on this? So I would request and appeal to everyone to seriously map it with the existing system, and it needs an action immediately rather than waiting for someone to do it first and then we follow. So be a leader, not a follower, and seriously look into this and let us do something good for the society. So thank you very much for your patience hearing. I hope you have liked this presentation on this technology of BAT. And this is what is on the dry separation. I would just like to introduce a small slide, one slide before I close. As you know, there are some, because this technology, imported technology, the technology cost is there. Maybe there are, in this category of mustard husk especially, there are very small plants also which are operating. They do not have that high budget for these emission controls. The boiler size is maybe 8 tons, 7 tons, 10 tons or 12 tons. But the budgetary constraint is there. Or they do not have problem with the slurry dewatering or the wet system. For those category of customers, we have launched an Enviropol multi-stage scrubber. We call it as EMSS. And that is designed for below 50 milligram, a low-cost solution as an alternate to those plants where the boiler size is smaller and there is a budgetary constraint. And water scarcity is not there. They can have water for scrubber. So there, for difficult fuel and for normal biomass also in sugar industry for bagasse and others, we have launched this Enviropol MSS multi-stage scrubbing with 3 stages of scrubbing and guaranteeing below 50 milligram per normal meter cube. On mustard husk and paddy straw especially, there would be definitely some concerns on the downstream system, on the dewatering system. So there also we have some models, so that mechanized model to operate and remove those solids from the slurry. In those cases, some bleeding has to be done to maintain the TDS to their existing ETPs plant. So this is just an option, but if you ask me which is the bet for paddy straw, I would say it is a dry system. Similarly for mustard husk, the dry system is the bet, not the wet system as far as these two fuels are concerned. For a simplified biomass like rice husk, like bagasse, like wood chips, you can use this scrubbers in a much better way than these difficult biomasses. So thank you so much for your patience hearing once again. And I would now request everyone to type their questions in the Q&A box only. We will not be picking up questions from the chat box. So please do write in the Q&A box. We will try to reply as much as possible, all the questions. If something remaining unanswered by mistake or because of time, we promise you to come back within next 48 hours on an email reply to you directly. Thank you so much. And we look forward to see you again with some new announcements shortly. Thank you once again. And now we start the Q&A session after 1 minute of break. Prakhar, would you like to proceed with the participation certificate or now or after the Q&A?
After the Q&A.
Okay, okay.
Participation certificate will be awarded after the Q&A. I will send the link in the chat box. From there, they can download it after the Q&A session.
Okay. So thank you so much. There are a couple of questions here. Around 10 to 15 questions are there so far. So let me pick up one by one. Okay. The first question is from Mr. Atul Valero. He says, which area silica ingress in ash? Mr. Atul, I am not very clear on this. What is exactly your question? Which area silica ingress in ash? Can you just rephrase your question and put it again? I'll take it up next. Then another question is from Sachin Kumar. What will be the DP loss in EGB? Mr. Sachin, the DP loss in EGB varies from 60 to 100 millimeter water column, depending on the requirement of efficiency. And in many cases, the booster fan or the existing ID fan may have to be upgraded. So 60 to 100 mm you can take for these fuels. Next question is from Mr. Dalip Chatwal. Ambient air quality index monitoring system installation is the part of control. Ambient air quality index monitoring system installation is the part of control. Yes, Mr. Dalip, I think this is the information which he would like to give. Thank you. Mr. Prabhu, why white smoke on chimney? How to avoid? Okay. Mr. Prabhu, which fuel you are talking? Normally with these fuel where the high alkalis are present, the white smoke is visible Number one, due to the high moisture content in the fuel, if it is a high moisture liquid fuel or if it is a solid fuel, even with high moisture, the white smoke sometimes is visible after the chimney. Plus the white smoke on these fuel are basically also a very fine particulate. We call it of these chemicals or these alkalis which are visible in the atmosphere. So most of the time, if your gas is clean, absolutely, then the white smoke disappears after few meters after the chimney. And if that is so, then you take it as a water vapors. But if it is not disappearing, it is showing a long line after the chimney. That means some chemical or these particles are still going, which are ultra fines being escaped from the system. I hope I have clarified. Mr. Mohit Jain, what is the approximate budget for a 10-ton boiler running on mustard husk? Mr. Mohit, on the commercial side, I think we can talk one-to-one because the budgetary cost has lot of implications on many things. Budget, the layout, and what is the pre-dust collection system you have already? Do you have a Cyclone or do you have ESP on this? So we shall be talking separately, Mr. Mohit. My team will definitely contact you and tell you about the budget after getting these details. Next question is from Ankita. Why we are using gravels? Yes, interesting question, Ankita. Thank you so much for raising it. In fact, anything which is not conducive can be used, but gravels being the low cost and easily available, we are using gravels. The whatever material you are using has to be inert. It has to be hard so that it doesn't get cracked so easily. So these are couple of characteristics which are required for remove. And also when you are cleaning it, it is getting vibrated. So anything which cannot broken so easily could also another factor. So I think the topmost criteria is the non-conductor of electricity plus its cost, low cost and hard. These are the three basic criteria because of which all these innovations were done on gravels. Yes, as you said rightly, we are also having something in mind to use some other material other than gravel and make it as a multi-pollutant removal system. So we are working on that and we'll come back once we are through with our development process. Yes, Mr. Dilip, does your system have online monitoring of pollutants? If yes, this is linked to pollution control. Yes, the online monitoring depends on the particular factory. If it is coming in that range, then they will have to put it online monitoring. It does not have normally on the system, it has on the chimney side. But yes, in most of the plant now the CEMs are there. Where we did it in India, Mr. Chandan Kumar Pila, where we did it in India on a spend was, we have done it at Dorala Sugar and the second installation is under execution at Dalmia. 2 installations. Mr. Anand Tyagi, what is the approximate budget for 18-ton boiler on mustard husk? As I mentioned, Anandji, we will talk on one-to-one basis as far as the budget is concerned after knowing your pre-dust collection and the layout. So my team, please note to talk to Mr. Anand and get these informations. Mr. Gunashekaran, can we use EFB for? Yes, of course, EFB. We have been discussing this particular cyclo EGB for EFB in Malaysia and some other countries. And this is a very good solution for EFB where the similar characteristics are there and you have a 5 to 6 gram as input. So simple cyclo EGB can be used. And on the existing retrofit, most of the plants of palm industry are having cyclones already. So you just have to add EGB. And for a new setup, we can have a cyclo EGB in place. So EFB is one of our focus area other than mustard husk and paddy straw for EGB. Another question from Gunashekar, we need personal meeting for discuss to install our upcoming project. Please send invitation to info Energy. Yes, Mr. Gunashekaran, my team has already noted your email and details, and we will be in touch with you in next 24 hours. Thank you so much. Sunil Kumar Singh, if MDC outlet is 500, yes, we can use Sunil ji. If MDC outlet is 500, we can easily use, and you can even target below 10 milligram. How many Cyclo plus EGB have you installed and what are the feedback from customer? Mr. Himanshu Chauhan, in India, so far we have used it on a very high concentration of dust application, which is spent wash. But outside India, there have been installations like I showed you in Sweden, that is followed by a cyclone only on a rubber wood fired boiler. And in India, yes, we are in the process of now installation of couple of new projects, but so far it is on ESP plus EGB for 30 grams input dust concentration on a spent wash. Outside India, we have many. Can we use Cyclone EGB with 30 TPS boiler, EFB, Napier grass, rice husk, multi-fired boiler? Yes, of course, Guna, but if it is a proportion of rice husk, you can use. But if boiler is designed for 100% rice husk, then your input dust concentration is going to be more than 15-16 grams. In that case, Cyclone may not give you less than 2 grams. But yes, if we design a good Cyclone at 120 or 100 mm water column pressure drop, this combination can be worked even on 100% rice firing. But for other EFB and Napier grass, there is no problem. You can work on a 30 TPH Cyclo EGB very easily. Next question from Vikas Paul. What size of gravel used for long-term operation of EGB? Vikasji, gravel size depends on the efficiency requirement. And as a thumb rule, if I tell you, it varies from 3 mm to 12 mm. We need to have a right mix of the gravel sizing to have a good wall of the gravels within the EGB for a better efficiency. Next question is again from Sunil. If MDC outlet is 500, what will be the output? Yes, as I told you, if MDC output is 500, the EGB can give you below 10 milligram also very easily. Yes, Mohitji, if Cyclone is installed, yes, we will come back with this. Then you need only EGB in that case, and your total budgetary cost will come down. We shall discuss it on budget part. Mr. Prabhu, our SPM level below 25 milligram is still white smoke is coming through this EGB can avoid fuel is wood chips and sawdust. Okay. White. We would like to study this case, Mr. Prabhu. Please send us the flue gas composition and your ash composition. If the white smoke is because of the fine particulate escaping from the existing system, then definitely it can be captured in EGB. But if it is because of the water vapors, then EGB cannot do anything. So we will have to see because of what reasons this whiteness of the smoke is coming. And as I mentioned to you, you can see it very clearly. If the smoke is traveling to a longer distance, then it means these are the ultra fine or the submicronic particles which are going with it. If it is not visible after few meters of travel, that means it is the water vapors which gets evaporated immediately it leaves the chimney. So you can please send us the detail. It looks to be an interesting case when you have a 25 milligram and still you are having this white smoke coming out of the chimney, especially on wood chips and sawdust. On the wood chips, I have seen the boiler running at 6 milligram in Sweden and there was nothing visible of that. Next question, Mr. Sunil, any installation on mustard gas in India? No, Mr. Sunil, not yet. And you could be the first one to do that. So we are just discussing with various stakeholders on this, and maybe very soon we are going to have it in India on mustard husk. Mr. Deepankar Das, do you have any installation on any boiler 18 with biomass bracket? We have installation, but not on EGB on this particular in India. But outside India, we our collaborators have got many installations on briquettes and many other difficult composition of fuels. How many EGBs have you installed till date? Our collaborators have done 90 plus. We have done in India 2, and we are in process of doing another 3. Thank you, Mohit. I think it replies your question. Next is Mr. Hemant Thakur. On rice husk, what's control required? Control, you are talking of E&I, electrical and instrumentation control, or what? Mr. Hemant, can you rephrase your questions? I'm not clear what control you are talking about. Is there any installation in India? Yes, there are installation in India, as I mentioned. Results, as I told you, 30 grams before 2-field ESP, followed by 2 grams after ESP, and then after EGB below 50 milligram. The one which we are doing right now is designed for below 30. On electrical control, yes, it has got a proper dedicated PLC, and it controls many factors like gravel speed, the gravel level, this dedusting cyclone delta P, and the bucket elevator speed, and gravel feeder speed, VFD control. So it has got a proper and established control philosophy which is in place, and which is working nicely wherever we have done or our collaborator has done these installations. Gravel replacing time, as I mentioned to you, in 1 year, you need 10 to 20% replenishment only. What happens, it maintains the level. So there is a gravel hopper which has an inventory. So as soon as the level is down, the gravel hopper replenish the level automatically. It is on in control mode. And if you ask me about the quantity, as I mentioned to you, per day basis, it is not more than 5 to 10 kgs, because it collects some dust, the fine gravels or the broken gravels through a grit separator, and that maintains the level automatically. So it is almost negligible. I mean, it runs for 2 years, 3 years, just by 10 to 20% replenishment over a period of 1 year. Is that on process boiler installed? Yes, it is a process boiler, of course. Mr. Gunashekaran, coal plus wood chips, fuel fired, can use any technology? Can we use any of the technology instead of ESP? Yes, coal, wood chips, and fired boiler, you can use this technology. You can use Cyclo EGB as a solution, alternate solution to ESP. So friends, thank you so much. I think I have a couple of more questions. Let me just complete. Mr. Mukherjee, can EGB be extended to coal fly ash for old ESP? You are in India. Yes, of course, Mr. Mukherjee, this can be applied. But the only thing is, as you go to the thermal power plant, the multiple units will have to be there because the quantity of flue gas is very high, and this is a modular design. So we have worked for a 100-ton boiler, some proposal, and if you have a 100-ton boiler, there are 4 units coming. So it becomes slightly expensive as far as you have the bigger size of boiler. But yes, of course, it can be very well used as an extension to ESP. Wherever the ESP, the space is not available for upgradation, this could be an ideal solution for those plants. Yes, Mr. Gunashekar, in municipal solid-based fired boiler, there is installation in USA on this EGB. And if you have something coming up, we can get more details from our collaborators and discuss on this MSW case. There is installation in, I think, Canada or USA for this EGB. So friends, this was the last question which I was having on my screen. Thank you so much once again, and looking forward to see you with a new program, with a new session, and maybe with some good technology once again. Thank you so much. Thank you. Thank you. Bye-bye. Have a good time. Thank you.
Um, Everyone can download their certificate with the link given in the chat box.